I'll record the session. If any of your friends need the recording, they can request from me. Okay. All right. So in case you guys, I think most of you have not seen me before. My name is Brian. And we will be doing physics. Okay, last session already, last 2 hours. I don't know how many attended the bio, the math session, but usually the last session of any seminar from experience is always the lowest turnout one, because you guys no more stamina and you died by the end of it. Huh? That's fine. That's fine. I just hope that you learned something from today's session. 2 hours is a very short time, right? 2 hours is a very short time. You guys have learned physics for like what, 4 months? 4 months. And for me to revise the 4 months in 2 hours is quite impossible. Okay, so I'll pick and choose lah. I'll pick and choose. And hopefully I give you guys some hints on like, how do you approach the subject? How do you look at physics as a subject and how to study, I guess, right? Many people say, I don't know where to start. For example, I think, is your school exam also going to be until chapter 3.1? 3.1, huh? Until 3.1, 3.2 don't have, huh? Okay, yeah, so same now for a lot of schools is until 3.1. Then a lot of people say, oh, 3.1 is such a mess. You've learned so many formulas. Have you guys learned 3.1 in school though? You have, huh? 3.1 is a mess. I don't know what's going on in 3.1, or it just seems very long. But really, there's just 4 things that you need to know in 3.1. Okay, we'll go through that. So my plan today, in these 2 hours, is we'll go through the first hour. I'll give you guys a 5 minutes break, and then we'll come back again. And in the last 30 minutes, I'll do chapter 3.1. Okay, in the last 30 minutes. So if I go over time, whatever I do, I will just stop and I'll continue chapter 3, just so that we have enough time. Also, one more thing. Later on, maybe tonight, whatever I write here, I will post in the group again so that you have a copy of my answer and stuff. And also anything that I cannot finish, because I confirm cannot finish this. There's too many things in 2 hours. Confirm cannot finish. So whatever I cannot finish, I'll give all my answers, but I'll write some explanation now wherever there needs explanation. Maybe things that you need to take note and all. You look through, you will understand. Okay, so yeah, whatever I write here later I'll send also. Okay, we will start, but I'm not going to do chapter 1. Right, chapter 1 is just measurement. Know your quantities. How many types of quantities? 4 quantities. You have your base quantity. How many base quantities are there? 4. How many base quantities are there? There are 7. You must know all 7. You must know the symbols of all 7. For SPM also, you must know the symbols of all 7. You must know the units of all 7. What is the unit for, let's say, electric current? Ampere, yes. What is thermodynamic temperature? Do you know what's thermodynamic temperature? Yes, Kelvin lah, right? Kelvin's there. Okay, not degrees Celsius. It is Kelvin. Thermodynamic just means that the temperature is measured in Kelvin and not in degrees Celsius. So later on in a lot of higher level, when you learn higher level physics, you'll start to learn a lot of things in Kelvin, and you realize a lot of things are not so much in degrees Celsius. So most of the things are in Kelvin. That's why they are stressing on the word thermodynamic. Hello. Okay, we'll start. Okay, but don't worry, later on you guys can try, and the solution will be given. Chapter 2 is the real deal, right? For chapter 2, guys, let's say if I ask you, what is that one most important thing you learn about in inertia? What is that one most important thing? Okay, inertia first. If I ask you inertia, do you know what's that one thing that you have to know? Just one thing. It's a very simple topic, but what is it that you guys have to know? Okay, it is related to the physics. Yeah, you cannot count inertia. but that is all extra, right? You guys need to know how to apply inertia in a inertia question, right? The thing that you need to know really is just the bigger the mass, the bigger the inertia. So if they give you a whole paper 2 question just on inertia, it would be this. You'll be talking about this. Okay, you mentioned about the laws. Okay, let's get into the laws. A lot of people also don't know what is first law, what is second law, what is third law. The fact is, most of the time, if you are lucky, you will never be tested in the 2 years. You will never be tested the definition at all. Okay, you'll never be tested the definition at all. If you are lucky, okay, if you are lucky, then too bad. But it's just 1 mark, guys, definition. Okay, 1 mark. What is more important is if I give you a question, I give you like a whole situation, and then I ask you what law is this related to, right? So you need to be able to tell me lah. So let's say the question is about something, and then got one question they ask you to draw a graph that looks like this. If I just give you this graph, do you all know what law is this? Yeah, what law is that? Law of momentum, is there such a law? Okay, I think I got most of you there. Newton's second law of motion. Okay, let me just give it to you straight. Guys, Newton's first law is talking about mainly inertia. Okay, I'm not talking about the definition. I'm talking about what is it about. Okay, I'm talking about what is it about. So if the question is about inertia, maybe they compare an elephant and a toy car. Which one is more difficult to move and stuff? You know it's inertia. Then you can say, oh, it's Newton's first law. Not enough lah. Newton's first law of motion. Why need to write of motion? Why of motion so important? Yeah, Newton is such a great guy. There's too many laws, right? So there's laws of motion. There's universal law of gravitation. Everything has to do with Newton, right? So please state of motion, and that is about inertia. Okay. Second law. Second law is talking about if the question is relating anything about force or mass or acceleration, it is second law. Okay. What is third law? Third law, not really momentum. Third law is more towards action and reaction. For every action, there is an equal and opposite reaction, right? So for action and reaction, it's more towards impulsive force, that kind of stuff. Okay, but this is the least popular one. Okay, so I hope right at the start of this seminar, you already learned something. Just one word you need to know. This is about inertia. This is about F equals ma. This is about action and reaction. In 3.2 also, chapter 3, you learn about Kepler's law. Also got 1, 2, 3. How I teach my students also, just one word lah. Kepler's first law, the keyword is ellipse. Second law, you're not tested this one. Equal area, equal time. Third law, it's all about the period, T squared to R cube. So yeah, think of ways to help you to remember. If you remember it, the definition word for word, you have done that already. Okay, good for you. But do you really understand the definition and know how to apply it? That's another story. Okay, so those are the laws lah, right? So I'm just trying to highlight to you here in physics. I'm not talking about other subjects, other science subjects. In physics, a lot of your subtopics sometimes it's just highlighting on one key concept, sometimes 2, sometimes 3. Okay, but a lot of the times it's quite specific what you need to know. And exam, they'll ask you that, right? That one thing that you have to know. Okay, so today we'll go through a bit here and there. And if I touch on a certain topic, I will elaborate a bit. Then you can write down those notes. We'll start with question number 1. A very simple one. Your midterm most likely will ask you to do some simple calculation like this. Diagram 1 shows a car which is initially at rest. Initially at rest. That's a keyword. At rest means what? 0. What is 0? Velocity is 0. Is it u or is it v? Are you guys ever confused when is it u and when is it v? if you ever forget when is it U, when is it V, it's in alphabetical order one. Sing your alphabet song like U, V, W, X, Y, Z. U starts first. U start first. U is called initial. You don't like the word initial, it's the same as starting. It's in alphabetical order, remember that. This is final. Okay, final velocity. So at first, initially at rest, meaning 0 meter per second, right? That is U. Travels uniformly in a straight line, reach a velocity of, this one final velocity. Okay, you will reach a certain velocity. This is the time. Okay, question, what is the meaning of velocity? Rate of change of, oh, you guys pandai, yeah, very good. Rate of change of displacement. What does rate mean? Rate relates to time. To those of you who don't know this definition, no shame, don't worry, just pull out your formula. Velocity is equals to displacement divided by time, right? Normally we write S over T. Anytime when there is time involved, we would normally mention the word rate. Rate means what? Rate means how fast, how slow. How fast, how slow means it's talking about time, right? That's why I got time, you will have rate. Okay, right? So don't memorize everything blindly. Sometimes it's just in the formula, right? How much the displacement change as time goes by, how fast or how slow the displacement change. Okay, calculate the acceleration of the car. You know what to apply or not if you see something like this. You want to find a, yeah, suvat, right? SUVAT. You see, they give you so many symbols for a reason, right? It's trying to tell you, can you please use your suvat, SUVAT. So there is V, or there's U, there's T equals to 3. Oops, 3. Okay. A lot of people always misunderstand this. So a lot of people say, oh, I only have 3 information, right? I only have 3 information. But can you always please include the one that you are looking for as well to make it 4? Okay, for you to be able to do your suvat questions, your suvat calculation question, meaning your linear motion questions, equations, it has to be how many symbols every time? You need to have how many? Can it be 5 or not? Don't know. Can it be 3 or not? Not sure. It has to be 4. It has to be 4 symbols. Cannot be 2, cannot be 3, cannot be 5. It has to be 4 symbols only. Then you ask me, how come, teacher, how come? Let's see the formula sheet. This one is formula sheet from SPM 2021. You see lah, got how many symbols? Let's count. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The T is already there lah. 1, 2, 3, 4. It is never 3, never 2, never 5. It is always 4. Okay, it is always 4. So you must make sure that you get 4, and one of it is the one that you are looking for. Okay, including the A lah. So you look at this, you realize, oh, this one other S lah, don't have S. You go and look at your formula sheet. Got S, the one, got S, the one, got S, the one. This one. Okay, it's never a problem which formula to pick one. If you are ever lost with that, refer to your formula sheet given to you. Given to you. The one S got no S. Got 5 symbols only. Confirm one don't have one. Then I don't want that. I don't want S. And that is number 1. Okay, V equals to U plus AT. Just make sure everything is in SI unit. Then you don't have to worry for your final answer. It will naturally be in SI unit. I do slowly lah. Those who very pro one in maths, you at least write the formula, write the substitution, and then write your final answer with the correct unit. Okay, so let me tell you guys something. In SPM, school maybe they don't do this lah, but in SPM, they are quite lenient one. If let's say you screw up here at one of the values you sub in wrong, too kanjiong or what, don't know. But you wrote out the formula. You will be given a mark here, 70% of the time. Okay, you will be given a mark here. So that's why it's a good habit to write out what formula you're using first, then you submit. Always show this too, then also your final answer. We don't care about the math stuff. So how fast or how slow you want to do, that's up to you. Okay, next one, displacement of the car. So that is S lah, displacement is S. And then you look at all these things, you think, oh, teacher, I got so many things. I got V equals 15, U equals to 0, T equals to 3. And then I got A also. Just now I just found A is 5. There's too many. How many can it be? 4. If got too many, do what? Cross out one lah. Okay, cross out one. Anyone. I prefer to cross out A. Yeah, maybe because, okay, thank you. Maybe because A is the one that maybe I screw up here in case, right? So the one now, this one. You want also can. So SVUT, we don't want A, don't want A. So I go and look at my formula sheet. Who don't have A? Let's see. Got A, I don't want. Got A, I don't want. Got A, I don't want. Okay, I didn't give you this formula sheet. Maybe later I send to the group in case you want it. So that's formula number 2, right? So choosing is not an issue. S equals to 1/2 U plus V T. Okay, submit. I think it's 45/2, 22.5. Displacement is what unit? Meter, thank you. And also, I realize a lot of people always don't know when do we say got acceleration or not. Okay, guys, acceleration means what? Yeah, increasing velocity, decreasing velocity. In simple English, we say acceleration is got speed up or not. Okay, got speed up or not. As simple as that. If this thing got speed up, got acceleration. If this thing never speed up, same speed, driving in a car, same speed only, then no acceleration. Zero acceleration, no acceleration. So you ask yourself, got acceleration means got speed up. I like this question, ticker tape. Actually, what's the point of learning ticker tape? You learn ticker tape for what? To count acceleration. Do you say count acceleration? To calculate the acceleration? Yeah, can calculate counting. Is that really it? There's force in here, really? There's force in here? To find gravitational acceleration, oh, I'm getting all sorts of things. Guys, it's as simple as, you know, the pro way in your textbook, we say, oh, to analyze the motion. But simple English, we say what? See the type of motion. If you don't like the word motion, motion is the same meaning as movement. The whole point of learning this is to see whether the trolley is getting faster, the trolley is getting slower, the trolley is same speed. That's it. That's the whole point of learning ticker timer. Now, how to see the type of motion? You see this tape, how you know is getting faster or slower or how? Yeah, distance between. Be careful of when you use the word tick. Okay, later I'll go through with that. The distance between the two dots, or guys, you just see the gap. Very simple. Bigger gap means faster or slower? Faster. Bigger gap means faster. As simple as that. But where's the start and where's the end? Is it the left side or the right side? Is it P or T? Which is the start? Okay, always look at the arrowhead. The arrow will tell you where you start. Don't mix up, You mix up then GGD. Then the whole question you do terbalik. Okay, the arrow will be the start. This is the end. Okay, sometimes the arrow is on the other side. No, don't always think left side is start. It's not always the case. Okay, then how to see? Do you see the gap? You start from here. The gap getting bigger. Bigger gap means faster. So if I ask you what type of motion, confirm will ask. If they ask ticker tape, confirm they will ask what type of motion. You need to tell them, oh, increasing velocity faster, right? Increasing speed, increasing velocity, or there is acceleration. But do we know whether the acceleration is constant or not? Then we will need to look at how does the gap get bigger? It gets bigger by a plus 0.8 every time, if you notice. If it's consistent, if it's a consistent addition, then it's a bigger gap and a uniform one, right? So we say, like straight away, I look at this tape, I straight away can say, oh, increasing velocity. Okay, this English is gonna be weird. Okay, uniformly. Okay, can I redo this? Velocity is increasing uniformly. I don't like the English. Same meaning lah. We don't care about English one in physics. Huh? Velocity is increasing uniformly. That is one answer that you can put, or you can say, what kind of acceleration is this? Is it uniform, increasing, decreasing? Uniform, you can say uniform, you can say constant also can. A lot of people always mix up constant and zero acceleration. Remember, if you ever confuse what is acceleration, you ask yourself, acceleration means got speed up or not? Got speed up or not? Got means got some acceleration. Maybe the acceleration value is just a fixed value, just maybe a 2 meters per second square. Okay, but when you say zero acceleration, it means never speed up. That means it is all 3.2 cm, 3.2 cm every time. That one is called zero acceleration, never speed up. Yes, Sanjay, can, no problem. Actually, I've done this seminar one time also before, other place lah. So Sanjay has joined that before. Yes, Sanjay, I know you love me a lot. No worries. Okay. All right. So yeah, so that is what they will ask lah usually, and usually people make mistakes here because you guys are so focused about the calculation, you see, that you forget about actually the whole point of ticker timer is actually this only, right? To see the gap and to see whether what kind of motion. Okay, now let's start answering some question. Some keywords. 50 hertz is the frequency. That means they will dot 50 times in 1 second. 50 hertz means how many times per second? Okay, so this is the movement of a trolley. Thank you, Sanjay. Okay, underline the correct answer in the bracket to complete the sentence below. Okay, the type of current used by the ticker timer is what kind of current? Yes, it has to be alternating current. Direct current is when you connect it to a battery. Okay, when you connect it to a battery. So a direct current, you think of it like this, it just supplies a current and the ticker timer will just dot there, which is not what you want. What does a ticker timer do? Vibrate, dot, 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 dot. And alternating current is like it turns on, turn off, turn on, turn off 50 times in 1 second. So we need it to dot, dot, dot. It has to be alternating, right? So got logic there one. You don't just memorize everything. Okay, next one. Determine the time taken from P to T. Okay, time taken. Before we do time taken, I have a question. 1 tick is blank space. Option A, distance. Option B, time. What to fill in the blank space? 1 tick is the distance or the time between 2 consecutive dots. Online people, this is your chance. Distance, a lot of people say distance. Okay. 1 tick is the what between 2 consecutive dots. Distance. All these people say distance one, not from my class, unfortunately. The one who say time, very good. Okay, those who say time, the one from my class one. Okay, very good. Okay, good job. Yes, it is time, right? Don't worry. It's the whole point of this is you learn something, right? So, okay, you learn something new, I hope, right? It is time. It is the time. It is never the distance. That's why I said, when you say, oh, we see the do you notice when I say here, I didn't say bigger tick, right? Because the tick is always 0.02 seconds. I say bigger gap because gap is the distance. Okay, so guys, the tick is forever the same one. One tick is always forever 0.02 seconds, right? Because 1 second, you tick 50 times. So you divide by 50, you get 0.02 seconds. All right, so the time taken to travel from P to T. I know you all know the answer, but what if they ask you the definition? Right, at least now you know it is 1 tick, 2 tick, 3 tick, 4 tick, 4 ticks. So the time taken is 4 ticks. And 4 ticks means 4 times 0.02 seconds. Must have units. A simple question. Okay, a very simple question that many people it's not just you guys. From 5 students, I ask them what is 1 tick distance always. Okay, we always think. I like to call it the gap because it's easy to understand. Or you want to be more specific, you say distance between 2 consecutive dots. Okay, so that's distance and time, don't mix up. Now let's find average velocity of the trolley. So the velocity of the trolley keep on changing now, right? But the average velocity, meaning you take the total distance and you divide by the total time. If you want to find average, you take the total over the total. So total time, we already know. Total distance, how much the trolley actually travel is just the total of all these things, 3.2 cm, right? 3.2, 4, 4.8, 5.6. Just know what unit you're dealing with. You want to change to meter also can. Don't need to write on the unit here. It's fine, but the final answer must write lah. Okay. I get a 17.6 on top. This one need to write, not don't need. You can straight away jump to the answer if you want. But answer, you must write properly, 220 cm per second. That's why unit is important, because if you don't write the unit, how will I know, right? Because you can totally leave your answer as 2.2 meter per second. Can, no problem. Okay. Acceleration, this is the one. Acceleration of the trolley. I think you guys, see, you notice that acceleration, velocity, all this counting, you guys can do. But remember, guys, physics is not a math subject. Physics is a science subject. Know how to apply, right? You know how to count everything, very good. Okay, you need to know how to count, and then you can understand well better. But it's a science subject. You need to know how to apply. Maybe only 10 to 15% is calculation in SPM. The rest is all writing in words, in theory one. It's facts. Yeah. So acceleration of the trolley. Okay. Acceleration is final velocity minus initial velocity over time. Why we need to minus? Because that is the change in velocity. So looking at the formula, you can also derive your own definition. It's remember just now I say T means rate. You take final minus initial, that is looking for the change in the velocity. So rate of change of velocity, right? That's acceleration. Okay, so let's go and calculate the U and the V first. The first part here will give you the U. The last part here will give you the V. So okay, go. I'm going to calculate the U here. That is the distance divided by 1 tick. I'm focusing on 3.2 cm only. 3.2 cm is how many ticks? Just one. Just one. 0.02 seconds. Okay, you do it down there. I do it in the diagram here so that you all can see where I get the values from. 160 cm in 1 second. You want to do 1.6 meter per second? Can, no problem. Then the V. The A is the important one, right? Because the A got trapped one, right? You know what I'm talking about? That's great. What's the trap in calculating A? Got something weird you need to do. Always people tell me, teacher, this physics are very weird. I don't know why this one needs to minus by 1. Do you remember that something need to minus by 1? Yeah. How come the V don't need to minus and then the A need to minus? Got logic one. Yeah, minus 1 thing. Thank you very much. All this from my class one. Okay, so 280 minus 160 divided by, if you happily go and say, oh, 1, 2, 3, 4, and then you do your 0.08, congratulations. Okay, cannot, this one is wrong. So the time, be careful. You write down there got space. I squeeze all here because I want to refer to the diagram. Minus 1 tick, or sometimes it's 1 strip. Okay, later I tell you when is it 1 whole strip. So you minus either, so this is tick by tick. You're analyzing tick by tick. Sometimes you are analyzing strip by strip when they paste it on the graph paper. Later I show you. So either 1 tick or 1 strip. So this one is 1 tick because you're doing tick by tick. But only for acceleration. Okay, maybe I need to highlight this. Only for acceleration. For the U, for the V, for the anything else, don't need to minus. Okay. When you find U, when you find V, when you find just now what average velocity, please don't minus. Only for acceleration, you must minus 1 tick or 1 strip. Those are from my class. All this is in the exam checklist here, right? Or this is your exam checklist, the summary one that I do for you in chapter 2. Okay, so the time you use only 3 ticks. Okay, you use only 3 ticks, not 4. I will explain in a bit. Let's get the answer first. Why we need to minus 1. Okay, I get 2000. This was in cm per second, and this is in second again. So cm per second squared. Or you do if I make mistake, let me know. Okay, so either one. How come need to minus? Because guys, when you calculate the velocity of 160 cm per second in the first part there, it is not the velocity here. It is not the velocity here. It is the velocity at the middle. Why? Because even though, okay, we can see the whole strip like that, it's getting faster. So if I zoom in, here, this point is faster than this point even. Because as you go to the left, go to the right, my bad. If you go to the right, you are getting faster. So even in one strip, like if I zoom in like this, the left dot here is slower one, and then this side is slightly faster one. So when you calculate the value, right, you can't say it's the front or the back. You have to be fair. We say it's in the middle. So it is here that your value is 160, get it? And then it is here that your value is 280 cm per second. That is why you need to minus half a tick from the back, half a tick from the front, and that is minus 1 tick. At least now you get the logic. Hopefully it helps you to remember why you are doing things. So got reason one why we do things. Okay. Your teacher will tell you, okay, you just minus 1, then you remember or not, that is your problem. Okay, but I like to tell you why, right? I like to give you the reason, so you don't just like be a robot and just do everything what the teacher say. Okay, can I also done 20 meter per second squared. This is the one. This is what I call as analyzing it strip by strip, one strip by one strip. So actually, I hope you all know that it is actually one very long strip, and then they cut. But guys, the way they cut, right, needs to be in a way that is like there's some rules to cut this very long strip. Okay, there's some rules to cut this very long strips. So one strip will have the same number of ticks. Okay. Okay. Why is that an important information? Because sometimes you see the strip, right? They don't give you the how many dot like that, right? They don't need to give you sometimes, because maybe they are just asking you to analyze it. So you must know that if I got a very long strip and I go and cut, right? Why I need to make sure it's the same number of strips is because let's say if the first one only got 3, the next one, I don't know what you want to do. You decide that you want 10, and then here you decide that you just want 1. How to analyze like this? It's pointless to analyze this graph because they are all uneven, right? That is why I need to make sure maybe every strip is 5 or every strip is 10, or you want to use a nice Chinese number, everyone got 8, or if 4 is a good number to you, then everyone is 4 like that, right? So every strip must be the same number or else it's pointless to analyze this graph. Okay. So they ask you, describe the motion. SPM favorite, this one, they like to ask. 21, I think, got one question, structure question 6 or 7, something like that. Or was it one of the state paper? I can't remember. But they ask you, what is the motion of the objects? Got different motion now. Here got speed up or not? Did the strip get longer or not? No, because I say longer means faster. If all same length means never speed up. Same speed. So from X to Y, you can say something like this. We have same speed, or we have uniform. We normally don't like the right speed, right? Velocity. Okay, that's one answer that they can accept. They can also accept 0 acceleration. Either one. Dua betul. You just write one will do. If you still confuse 0 acceleration means got speed up or not, right? No speed up. So 0. Okay. Then from X to Y. Just now I say the whole point of learning ticker tape is to do what? See the gap. The gap get bigger, faster. The gap gets smaller, the length gets smaller, shorter means slow down, slower. That is called deceleration. Okay, so this is velocity decreasing. The English not so important, decreasing. Is it uniform? Okay, if it's uniform, you need to say uniform. Okay, if you don't know how to see, you see the gap. Minus 2 cm, minus 2 cm, minus 2 cm. Yeah, okay. The misconception is that always people think it's 10 ticks, but it doesn't always have to be 10. Like I said, so it can be any ticks. Like, can I say uniform deceleration? Yep, you can. I was going to get there. It is a uniform or a constant also can. Deceleration. Deceleration only has one C when you spell it. Acceleration has 2 C's. Okay, deceleration only has 1 C. English is weird. Okay, next. Graph. Okay, this is one of the things that a lot of people don't like lah. I think it's quite polarizing, the answers. Either you like or you hate it. Okay, let's go straight to the point. For graphs, this is what you need to know. You need to know how to convert this graph to this graph. Okay, and then ask a V graph to A graph. How to convert? If you go like this. Hey, don't know. You only learn one thing, and that is this, in the whole topic. Ayah, macam mana ni? Okay, this one also from my class. Okay, gradient, very good. Okay, moving forward, you must remember the order, super duper important. S, V, A. S is not speed, guys. S is displacement. Okay, S is displacement. Don't ask me why they use S. Just like that. Accept it. I've accepted it. You can move on. So SVA. So you have SVA, and that is moving forward. Moving forward, find gradient. Moving forward, find. Can you use purple arrow? Find gradient. Find gradient. Later I teach you how to. You know this. You know the whole topic. Okay. Moving backwards is fine. What's the opposite of gradient? Yes, area under graph. Okay, the only thing you need to know, and you have learned it straight away, I tell you, this is what you learn. Okay, I'll teach you how I apply this SVA concept. Remember, if you want trying to go forward, find gradient. If you're trying to go backwards, you can find the area underneath the graph. Okay, right. So for number 3, name the quantity that is determined by the gradient of the graph. Okay, I know most of you will know the answer already, but before that, can you guys? Very good. Okay. Good job, guys. Good job. Okay, all these are familiar names. I want you all to write this S V A. Okay, and you go and circle what graph is given to you. V graph. Okay, they give you V graph, you circle V. So you imagine you are this guy trying to walk lah. Okay, if they ask you to walk forward, means it's finding gradient. And finding the gradient means you will eventually get the acceleration. If they ask you to walk backwards, means you're going to end up finding the displacement and you are finding area under the graph. So gradient of the graph means walk where? Forward, forward. Okay, and that is acceleration. Make no more mistakes with this kind of things. SVA, circle what is given. Ask yourself, is the question asking you to walk front or walk back? Walk front is gradient, walk back is area. Can I go up? Yes, sure. Don't worry, later I will send this one for you also. Okay, and then they ask part B, what is the motion? Okay, they like to ask motion. I'll do it here. So for car A and car B, what is the motion? Okay, got a straightforward way to answer, and a more pro way to answer. Okay, let's look at car A. What do I say? A straightforward way and a pro way to answer. Okay, the straightforward way to answer what type of, this is part B, my bad. Part B. The straightforward way to answer this is you see what graph? V graph, and then you see the V straight line go up like this, means the V is going up. Then that is the straightforward way. You just say velocity increasing uniformly. You write in the next page, there's a table for you. Okay, so this is for car A. So this is the straightforward way. Just see the graph is talking about V, and then you see V go up, then increase uniformly. Okay. Or there's another answer. So you either write one in exam. If let's say you want to talk about acceleration or you want to talk about displacement, usually I don't want to touch about displacement now. It's easier to go forward one, trust me. It's a bit harder to go backwards. Okay, that is how it is. It's easier to go forward. And when I go forward, right? Okay, what is the gradient of this green line? Is it changing or is it a fixed value? It is a fixed value. If you be like, how these people know so fast? Okay, don't worry. Remember in Form 3, you learn y equals mx plus c. This is for what? For curve or for straight line? Forever straight line. Any straight line, whether straight like that, straight like that, straight like that. Straight, as long as it's straight, that one is going to give you a fixed gradient. A fixed gradient, just one gradient value. At this point, I think people the gradient value is, let's say 2. Here also will be 2. Here also will be 2. It's all the same value. And what is gradient? Gradient is the acceleration. Change the m to a. The a is same. It is a constant or uniform acceleration. Either one answer in exam. Okay, don't know, then don't worry, just use the direct one. They won't ask you to mention all of it unless it's an essay question. Okay, that you need to give more answers. Then car B. Okay, good job. Let's look at, now I use orange color. Okay, car B got 2 parts, and you need to describe 2 parts. Okay, so for the first part, for the first 3 seconds, for the first 3 seconds, that one velocity go up. So it's the same answer, right? So first, or you want to write from 0 to 3 seconds also can. First 3 seconds, same answer. Okay. After 3 seconds. After 3 seconds is what? Yeah, flat means what? Velocity is what? Constant. The velocity never changed. Does it mean that the car stopped there? No, okay, very good. It means that the car is moving, but at the same speed. Okay, so that one is called constant velocity. Good job, guys. Now you can answer it. Okay, constant velocity. That means that is the straightforward way lah. If you want to pattern a bit, you want to do the gradient one, the moving forward one. You got velocity graph. You want to do gradient. Okay, then you will see what kind of acceleration is that. Yeah, the gradient of any flat line like this. Okay, any line like this, the gradient is always 0. Okay, so the grade when we say the gradient is 0, it means the acceleration is 0. So that's one answer. Or you can write not constant, but 0 acceleration. Okay, can you all do part D? Sorry, part C and part D. Calculate the acceleration of the car in the first 3 seconds. So, yeah, very good. Okay, so for part C, right, you know the graph that you are given is a V graph. Okay, so like I always do, I'll tell my students, you can circle what graph is given to you. And if they say find acceleration, right, you can literally go and cross this word if you want and say find gradient also can. Because it is the same meaning, right? You know you're going forward, you're this guy trying to walk forward, and finding acceleration is the same as finding gradient. So all of a sudden, it's just a maths question. It's not so much of physics anymore, right? But how do you find for car A? For car A is the green color one. Huh? Do you have enough information in the first 3 seconds? No, right? We want to find the gradient of this. So how? Yeah, because I just said just now, right? It is the same gradient, right? Gradient here, same or not? Same or not? Same. So I can use any point. I will use this point because this point I got the value. So don't worry, they say 0 to 3 seconds, 0 to 10 seconds. Even further, it's all the same because it's the same straight line. It's part of the same straight line. This is 0, 0. Okay, how to find gradient? Y coordinate minus y coordinate. X coordinate minus X coordinate. Oh, sorry. X coordinate. Okay, that is your gradient. The gradient of the V graph is the acceleration. 2.4. 2.4 what? If not sure, you see the y-axis on top is meter per second. The x-axis is S lah. So meter per second squared. That is your answer for part C. Okay, later I'll arrange a bit lah. Right. Now it's all very messy. Okay, can you go and do the last one, part D? Calculate the displacement for B for the first 10 seconds. So that one we are looking for. And now you know it. This, right? And then you are doing V, and then you are walking backwards. You can literally cancel this word if you want and write it as area under the graph. Same meaning, it works the same way. Okay, so going backwards is finding area under the graph. You can find what's the name of this shape? Trapezium. You don't like trapezium, right? I'm not going to teach you on your maths. You want to do trapezium, you do trapezium. You don't want trapezium, you do triangle and rectangle. Can. As long as can get answer, then can it. Don't worry, right? I will do the trapezium one. Trapezium is just 1/2 a plus b times the height. The a and the b is the parallel sides. So that is 10. This is 7. And the height is 24. Okay. So you get S equals to 204 meters. Okay, 204 meters. Okay, let's move on. Question 4. Can you read through question 4, just roughly? Can you tell me what topic is this from? Yeah, this is C, this is D. Okay, Dana, I move on. Now and then question 4. If you see something like this, and if you still don't know what this is about, that means I don't know what you're learning, to be honest. Okay, you need to know exactly how you see collision. It is principle of conservation of momentum. Principle of conservation of momentum, right? The moment you see any kind of collision, whether is it elastic, remember got 3, whether is it inelastic, whether is it the kaboom one, explosion. But a lot of time, explosion doesn't really mean that it's going to explode, right? Because under explosion, we talk about things like rocket and stuff. It doesn't really explode, but it's just the name of it, okay? So what is the difference between elastic, inelastic, explosion? Okay, do you know what the kinetic energy is conserved mean? What does it mean when we say conserve? Doesn't change, okay? It doesn't change. Guys, you have to know what's the meaning of conserve, because whenever you see these 3 things, it is talking about the principle of conservation of momentum. And why I say you need to know the word conservation is because okay, guys, a lot of people say this principle very hard. In exam, they ask, I don't know how to answer. Midterm gonna come out for sure. Okay, your principle of conservation of momentum, one of the most popular questions in structure in essay. Number 2 is your impulsive force, your impulse, that one. So we're gonna go to that later. But guys, I always tell my class, principle of conservation of momentum is not difficult because everything is in the name. Conserve means maintain, means it remains the same. Okay, remains same. Okay, or it is maintained. Conserve means same or maintain. Okay, very important because immediately I know, oh, principle of, now you read it again, principle of conserving the momentum, meaning that immediately you will know, oh, they are trying to say total momentum is going to be unchanged, right? Total momentum before is equals to total momentum after. Okay, before collision and then after collision. Right? So the name will tell me that it's talking about this, right? And then the name also, yes, I spelled momentum wrong. Thank you very much. Apa ni, momentum. Thank you very much. Yes, please tell me if I make any mistakes. Okay, I highly appreciate it. Okay. Total momentum before collision equals to total momentum after collision, right? And guys, can one thing collide or not? Can one day you just walk, and then I say, oh, I collide with air like that? Got such thing or not? You need to collide with something, right? Got 2 things only can collide. Collide called what? Like, okay, I don't use the word bang, but collide means bang, right? It means like hit each other, right? That is what collide means, right? So collide means what? It has to be 2 things, yeah. And this word is quite important. So when we say momentum, right, it has to be total. So meaning you take momentum, which is the mass, times the velocity at the start, okay? And then the mass of this guy and the velocity at the start, right? It has to be two things only can collide. So you cannot add on its own like that one. So the total momentum, this is what I mean by total momentum, equals to the total momentum, after. Sorry. After means we use V. Will exam give you this formula? No, exam will just tell you what is momentum. Okay, exam will just tell you, oh, momentum is mass times velocity. Okay, mass times velocity. But now, isn't it just right? Why did I give you this? Because it's just writing the same thing 4 times. Right? Momentum of one thing and another thing, then hit each other, then equal to momentum of the two things and hit each other, right? So everything is in the name. Everything you need to know is in the name. The name tell you conserve, maintain the same. Then you know the formula. And this thing, right, is also your definition. What is the definition of the principle? If they ask you what is principle, they like to ask, what is principle of conservation of momentum? The principle of conservation of momentum says that the total momentum before collision is equal to the total momentum after collision. Okay, but just got one extra part. When no external force is applied, right, to the system. What is the meaning of external force? Yeah, one of the most, a lot of people don't know lah. Every time they say external force, apa tu lah, right? External force means it is the friction, right? Most of the time, you think of it as friction and can reduce. So this only works. It's a principle. It's a perfect situation. Under perfect situation, perfect circumstances, it will work. So we treat it as like a perfect situation where there is no friction and no air resistance and no any other kind of force. Okay, all those kinds are external force. So I'm just focusing to the system only, and I ignore everything else around it. That is what ignoring all the external force means. So external force, most of the time you think of friction good enough. Okay, that means like under a perfect situation. So I think I have explained everything you need to know to answer part A, part B, part C, part D. So I think I would want to take my time here to explain on more useful things. But meaning of momentum is one of the easiest definition, right? Because it's just in the formula, and the formula is given. Sorry. And velocity. To those of you who don't know what is the meaning of product means multiply, means times. Okay, so momentum is actually mass times velocity. Plus we call sum, minus we call difference, times we call product, divide we call ratio or quotient. Okay, right? So they ask you determine, okay, this one later when you have time you do that, but the total is just you plus together total is 4. Then you plus together the total is 4. Right? You can see what the question is trying to do. Total momentum is the same. It's equal, right? Okay. So I'll skip all this. We go to part E. Later on, I will give you your answer. Don't worry. Tonight, I will send the answer and all my working here. Okay. State the type of collision shown in diagram 4. What is the type of collision? Okay, inelastic. So it has to be one of these answers. If you don't know how to see, very simple. Elastic reminds you of what? Rubber band. Exactly. I always tell my class, elastic reminds me of rubber band. That means it will bounce off. Okay, it means that it will bounce off. After the collision, it will bounce off. Inelastic is the opposite of that. It sticks together. Okay, it will stick together. Then explosion is what? One go left, one go right. before the explosion, what is okay? Yeah, for explosion must be very important. Before everything must be resting one. Only explosion before is resting. Okay, then after that they will go opposite way, right? After it would be opposite but equal magnitude. Okay, so the answer for part E, don't worry, I'm going to get into explosion in a bit. Not I will explode, I will explain explosion. The type of collision is inelastic. Okay, I'll give you a break soon, inelastic collision, but let me explain one thing before you break. Inelastic collision, the reason very simple, you just have to say the toy car, is it toy car? The toy car will move together, stick together, combine together, up to you. Okay. Keyword is you say anything like you say like together, then can so move together, stick together, combine together after the collision. That's the reason. Okay, 1 mark for type of collision, 1 mark for why. So stick together. If they ask you why is it why is it elastic? Then you say, okay, they will separate, they will bounce off. Kaboom. Yes. Yes, Divesh, I will explain. I'll explain explosion. Yes. Okay. So before your break, I know I say I promise you guys a 5-minute break. Before your break, I want to explain your Kaboom. Okay. Which is this rocket. Can we go to page, what page is it? 13? 13. Okay, I won't have time, I think, for this essay question. I'll give you guys the answer. You guys know you have to do it in a table, right? Okay, you need to do it in a table. If you are not sure what to write, must do table, the 10 marks one, or 10 marks part. Okay, you do table. One side you write the reason. One side you write you want to write suggestion also can. The word not important one you write suggestion aspect whatever. It doesn't matter. It doesn't matter. We don't really care what you write here. Okay, so suggestion, modification, also can aspects. Okay, and then you list. Okay, just bear with me for 5 more minutes. Let me explain the working principle of a rocket. Many people ask me this. Many people don't know this, right? So a rocket is the classic example of explosion. Okay, if they give you a rocket, they ask you what is the physics principle of conservation of momentum, because explosion is the principle. Explosion is the principle. So you don't waste marks if they ask you this. So guys, you guys must know that for rockets, we don't use petrols in rocket. We use hydrogen and oxygen. There is a reason why we like to use this, because liquefied hydrogen and oxygen would give us enough of exhaust gas, produce a lot of exhaust gas, which is what you need for a rocket. Produce a lot of exhaust gas. Okay, produce a lot of exhaust gas so that it comes out a lot here. For cars, we don't need a lot of exhaust gas. We want to cut down as much exhaust gas as possible. So the exhaust gas will come out from here, right? Exhaust gas. Inside, you have a combustion chamber. What's the purpose of combustion chamber? Yeah, very simple. Just burn fuel. Okay. Burn fuel to create more exhaust gas, right? It's to burn the fuel. Okay, very simple. So how it works is that if they ask you a 4-mark question, very simple one. You say hydrogen and oxygen, these two will be sent to the combustion chamber to do what? To burn, right? To burn for what? To get your exhaust gas. Remember, rocket, very important thing is to get the exhaust gas Why we need the exhaust gas? Because we want to create a lot of downward momentum. When the exhaust gas rush out at a very high speed, it will have a lot of backward momentum. You want to write backward or downward also can. Okay, so this is when things get a bit confusing because the next part is I'm going to make use of my principle. Based on the principle of conservation of momentum, what does the name say? Momentum will stay the same. Momentum will be maintained, will be constant. So the total momentum before is equals to after. That's what they say, right? Before that, imagine your rocket is just stationary. Okay, your rocket is just stationary. Everything looks like it's very quiet. If you have never seen those olden day videos where they count down to the rocket launching, you should go and see one of those videos. They'll actually count down one, you know. They'll go 5, 4, 3, 2, 1, and then okay, the first rocket in history has gone to the moon, that kind of stuff. So they will count down, and the fact that they count down means that at first it's not moving. Everyone just waiting, suspense, and then kaboom, right? So before there is no momentum. Guys, only things that are moving has momentum, because momentum is mass times velocity. If velocity is 0, momentum is 0. Okay, that means nothing is moving. At rest, momentum is 0. And then after that, the exhaust gas will have its own momentum. The rocket will also gain its own momentum. Okay, you move it over, you get something like this. This is special only for explosion. Do I need to memorize this? I don't, because I always look at my principle and I ownself write out and then I ownself get this one, right? It's not difficult. So this is only for explosion. Okay, this is only for explosion where you have your M1V1, M2V2. A bit hard to see if I write like this. Maybe I give you guys some values. Okay, my pen is not cooperating. Wait, okay, not responding. Okay, wait, so this one is for the rocket or the exhaust gas also can. Okay, let's say this is for rocket lah. I give you an example. Maybe it is 1000 kg, okay, mass times velocity. It is. Then this one would be maybe for the exhaust gas. For example, negative 1000 kg meter per second. So that is the momentum, right? So you have some momentum going up and some momentum going down. The negative is because momentum is a vector quantity. It has direction, okay? It has direction. So the backward momentum, let's say, is negative 1000. Okay? Because you create this backward momentum, and based on the principle of conservation of momentum, for it to conserve, it must fulfill this. So therefore, the rocket will gain. Therefore, the rocket will gain that forward momentum. I don't want purple, I want red. So, okay, never mind. I think I'll stick to purple. Okay, so we have some forward momentum of 1000 kg meter per second as well. This is what we call as equal magnitude but opposite direction. Okay, so how to write in exam this whole story? Rocket uses liquefied hydrogen and oxygen, okay, which is sent to the combustion chamber. In the combustion chamber, the fuel is burned and then you get some exhaust gas, right? The exhaust gas will give you a lot of backward momentum, a very large backward momentum. Based on the principle of conservation of momentum, because there is a large backward momentum, and equal and opposite forward momentum is produced and the rocket can fly. Everything that I wrote here. Okay, does it have to be in order? No. Understand it, and then also ask yourself when in all this explanation question, you can try to use this this method of explanation, which is to think about what happens before, try to explain some before, try to explain some things during, and try to explain something after. Okay, this is something that I haven't really told my class yet, but this is the first time you guys are going to hear this. Okay, those of you from my class. So this is for your explanation questions, the 4 marks one usually. You guys are usually afraid of that. Okay, if you've done enough questions, this is usually the part that people don't like. Don't know where to start. So the before would mean like before even exploding, before even the explosion, you talk about the liquefied hydrogen, oxygen. That's the before. Then during is what happened. Okay, got exhaust gas, rocket move forward, principle. Sorry, during is principle. After is the rocket will move forward. So at least you have some idea of, if you are totally blank, every time you see this kind of question, you think, what happens before? What can I write before that is related, that is useful? Then what happens during? Then what will happen after, right? Before, during, after. Okay, I will give you your 5 minutes break. It is 2:45 now. Oh no, 2:45 now. We'll come back at 2:50. You want to go use toilet? You want to just sleep, play phone after you do whatever you want? Rest your brain, and then we come back in 5 minutes. Quick break. Oh, sorry. Just now I was telling them got nose cone and tail fin for the rocket, and then nose cone is more aerodynamic, right? I was telling them it's not a nose cylinder, it's not a nose cone. Yeah, it's the structure. It's the additional. You can call it as additional structure, but actually every rocket has it, so it's considered the structure. Okay. This 8 question, how come both the 8 fall and only 1 breaks? Okay, I know the question is talking about impulse, but it's not really about impulse. It's talking about the material, the force, the surface, right? What kind of force? The impulsive force, the impact force, right? So guys, when we talk about impulsive force, you will notice if you are very lost, you don't know what is impulse is talking about, or worst case, if you think that they are the same, please let me enlighten you that they are not the same. Please do not mix them up. Very important for your exam. Impulse is, okay, we look at the definition first, because the definition will tell us quite a bit of important info. The change in the momentum. While impulsive force is a force. What kind of force? An impact force. But the definition just add 1 extra word, rate. Meaning got time lah, rate of change of momentum. Okay, yeah, good job. So change in momentum. Just now, now we are talking about the change in momentum. We are not talking about collision. Just now we say 2 things. Only 2 things can collide. One person cannot collide on its own. But now we are talking about just one object, just one thing only. So the momentum of something at the start is m1, u1. The momentum of something at the end is m2. Sorry, there's no 1 and 2. My bad. Because it's just one object, right? So just mu, mv. Sorry. Okay, so the change in momentum, we always take final minus initial. Normally, impulse, we use the symbol J. Okay, so that is change in momentum. So the formula and definition, same thing. Okay, rate of change of momentum, you just add that extra, the time. Do we ever put time on top? No. Okay, even though it comes first, but it always goes last. Rate is divide 1. It is a force. It is a force. That's why it is F. Force is in what unit? Newton. That's why you all crack your head always. This formula is so hard. I don't know what's this talking about. Force, guys, it is Newton. It is in Newton. Okay, so the formula is like this, but for impulse, actually got one more very important formula. And that comes from your impulsive force. Okay, because Formula-wise, you just shift this guy up, then it becomes what? Ft equals to mv minus mu. So mv minus mu, it is also equals to Ft. Okay, this is important. So this is formula-wise lah, right? Formula-wise, I haven't really told you when to apply which one. For impulse, you must know this. If you don't know this, you will don't know how to apply. So for impulse, mainly what application do we do it for? What application do we do it for? Got you guys again. For impulse, what is the most important application? Usually what kind of question I will say, I'll talk about impulse. Follow through, right? Not follow through action. Okay, at least now you know, okay? Another new thing. Every day you learn something new. Follow through action. Oh, didn't know this? Really? Don't know? GGD. No, joking. Follow through action. What is follow through action? When you play golf, you don't just hit the ball and just stop there. You would hit the ball and you follow through, right? When you kick a football, you don't just touch the ball. You would kick the ball and you follow through. That one called follow through. Continue the movement. Okay, that one called follow through. What is the purpose of follow through? Let's see. To increase the time, because when you kick the football, okay, and you just tap it only, the ball cannot fly far. If you touch the ball for as long as possible and you kick it through, you would increase what we call as the time of action of force. So you are applying some force and you apply it for a longer time. Okay, so when we say follow through, you are trying to increase the time of action of the force. In simpler, okay, if that sounds confusing to you, the time of how long you apply the force. Okay, time of action of force means how long you apply the force. Important, huh? So let's look at the relationship when the T goes up, the impulse, you're applying the same force, you know, but just one guy kick longer time, one guy never follow through, one guy kick shorter time. He just tapped the ball like that. Okay, so the force is the same. They both apply the same amount of force. Just one guy lazy to follow through, right? So force is the same. The impulse would increase, so it will increase your impulse. And when you increase the impulse is what? Change in momentum. Your momentum will change a lot more lah. At first, what is the momentum of this ball? The ball's not moving. Okay, at first the ball is not moving. Okay, answer this. Don't worry. Okay, so at first the ball is not moving. Momentum is 0. So when we say the change in momentum is a lot higher, it means that from 0 now it will change to maybe a very large value. It will change a lot. That means the final velocity will be very high, higher velocity. In simple terms, follow through will help us to increase the time of action, to increase the impulse, to therefore increase the final velocity of the ball, so that your ball can fly further. The ball will not just, if you just tap the ball, it will it won't travel far. Okay, so you want it to go as far as possible. That's what you want for golf. That's what you want for football, right? Follow through action. Very, very important. Okay, then impulsive force. Impulsive force, what is most, usually they are talking about not the action, not the change in momentum. They are talking more about the material. Very good. Usually the material. Usually they talk about those soft stuff or those hard stuff. Okay. In simple English, right? Guys, impulsive force, like I said, okay, maybe you don't like the word impulsive, right? You think of it as like the force during the impact. So during the impact, if this piece of thing is soft, in simple English, maybe last time you all never learned about impulsive force, you guys will say, oh, if I put a sponge there, it will not break because it absorbs the shock, right? What happens when it absorbs the shock? The egg will sink into the sponge, The time of impact is greater, right? It slowly sinks into the sponge. So when it's softer, it will increase the time of impact. I want you to notice something. I usually don't talk about the time of action of force. So time of action of force is more towards follow through action. Impulsive force, I will say time of impact. Okay, so I don't want you guys to mix up these two because it will be very confusing when you try to do explanation question. So when the question is talking about mainly follow through and talking about how to move the ball to as far as possible, that is talking about increasing the impulse to increase velocity. But if the question is talking about dropping something and why one will break, one doesn't break, it's talking about the material, and that is impulsive force. We talk about the time of impact. Okay, so if you have higher time of impact, so what happens to the force? Decreases. Why? Because the F is on top, the T is down there, right? The F is on top, on its own means F over 1, right? F is on top, T is down there. One on top, one at the bottom, and must be on different sides. The equal sign is here. One must be on the left, one must be on the right. They are inversely proportional, meaning it would be opposite impulsive force. So you need to know when to use what, when to talk about what. So you don't talk about the wrong thing. Yes, I know that between impulse and impulsive force is the more popular one. But who knows? Maybe they can give you a question on it. Or who knows, maybe it's just an objective question, right? But at least now you know. Okay, so if it's very hard, then you have a short impact time. And then you have a very large force because it will just slap on the surface very hard. That is why high jump, you need a mattress, right? So, oh no. Okay, I don't know why I cannot use. So imagine you have high jump like this, right? They always put a mattress there. What if I remove the mattress? You just slap on the floor, then GG, you die, right? So why? Because you will just slap on the floor. There's nothing to absorb the shock. There's no extra time. The time is very short. But when you have the mattress, you slowly sink into the mattress. You increase the time. You reduce the force. Inversely proportional. Okay, it's 3:04 now. I need to go into chapter 3 or else I won't have time. But don't worry, later when you see the answers, you will understand one, right? All the things that is important, I explained already. Okay, so don't worry. Today you are trying to learn to know, like, okay, when to do what, when to apply what. Can we talk about this real quick? Sorry, I'm very greedy. I want to do everything. This is before, during, after. Okay, let's try this strategy here. So question E asks you to describe how a large force is produced by the pile hammer in driving the pile into the ground. So let's try to use this strategy for this explanation question before, during, and after. If you don't know, pile hammer and pile, right, is actually a nail and hammer concept. Same thing. If you know how a nail and hammer works, you will know how does a pile and pile hammer work. Same thing. You will just drop and then punch this guy, go into the ground. Okay, you need this cerucu or this pile into the ground because maybe you want to build a twin tower here. You need a very strong and stable structure. All right. So there's some pillars, some piles in there. Okay, so the piles are very strong. So let's talk about the before. What are some points I want to mention? They both have very hard surface. Hard is important, right? Do I use soft things? No, your hammer and nail is not made of rubber, right? It's made of metal, right? So that you have a very short time, right? So hard surface because time short, force large. You just elaborate on this. Out of 3 marks, you get 2 because that is what they are testing. They want more force, less time, more force, hard surface, all these things. You talk about it, right? And before you drop it, how to increase the momentum. You bring it higher, okay, you bring it higher. Momentum is mass times velocity. So you bring it higher, it has more time to accelerate. What is the value of the acceleration? It is usually about 9.81, right? Assuming that there's no air resistance and stuff. So during is that you drop it at a greater height, okay? You let it accelerate. Okay, you let it accelerate. You let it speed up until right before it want to hit the pile, it gets to a very high speed. It gets to a very high velocity. So right before the velocity here, very high, the momentum here, very high. Okay, so that you have a very large change in momentum, right? So high height, it accelerates and it hits the thing with in a short time. Okay, a lot of force produced. You mentioned all of that again, a lot of force produced. So after that, got a large force so that's what happens after. So I'm just trying to give you an idea if you are always stuck, at least now, okay, I have a certain direction. I'm not totally lost. I at least know what can I talk about. What do you think is related to? So of course, you need to have the knowledge. You need to know what this is about. If you talk about impulse, GGU, right? If you talk about impulse, gone case, you need to talk about impulsive force. So it's more towards impulsive force here. Okay. Got a bit of impulse because you lift it higher. When you drop it, the change of momentum is greater. There's more impulse here. But the focus is a bit more on impulsive force. Also, one more thing. If they ask essay question, this guy has a big mass. Because big mass, big momentum. Or big velocity, big momentum also. There's one more thing in chapter 2 that I want to say. Okay. You know, for this last one, I promise. Okay, last one. I really cannot just go without telling you this. Okay, so there's this essay question, right, that talks about number of tanks, how many tanks of tire. This is a lorry tanker, right? So if you don't know, yeah, this is talking about mostly inertia. So you have a tank, okay, and usually you have the tanker head, and then there's some distance here, and then there's some wheels. Okay, so later on, I'll give you the answer. I think you guys would understand what I say. But the small tank, right? What is the purpose of small tank? Oh, is it really? Is it really that? You're not going to get marks for that reason. So inside, from outside, it looks like a big tank, right? One big tank. But imagine this. We're carrying petroleum, highly flammable, under the hot sun some more. If you drive and then this truck keep on stopping and then going, stopping and then going, what happens inside? That maybe that 2000 kg or 1000 kg petroleum just keep on shaking back and forth, right? We don't want to keep on shaking it, right? When you shake your water, also got bubble, right? What more petroleum? And then some more under the hot sun. So we don't want that to happen. You cut down on the mass. Actually, the main thing is cutting down on the mass, right? Because when the mass is smaller, what happens? Smaller inertia. Next question, you all know what's inertia or not? Tendency of an object to remain at rest or continue moving at constant velocity in a straight line. That's the proper definition. But do you understand what that means? What is the simpler version of it? Let me tell you. Okay, you know definition, good for you. But what I like to do is teach you how to apply, right? Teach you what is the easy way to remember inertia. When you talk about inertia, you're so confident about what you're talking about. Inertia is just, okay, when we say, I think I give you a quick example. I think this would explain it all. I give you elephant versus toy car. I like to give this example. So elephant is very big mass. Big mass, big inertia. Apa maksud big inertia? Difficult to stop or move. So if it's moving, it's very hard to stop an elephant. Or if it's stopped there, it's very hard to push an elephant to move. Toy car, small mass, small inertia. Easy to stop or move. Okay, the distance between the tanker and the tanker head is talking about this. This is the distance that they're talking about. Okay, this is the distance. So you want it to be longer because you want to give it more time so that in case the truck hits on something very hard. Hey, hold on. A bit laggy. Yeah. Yeah, I can't change it just now. Okay. So if let's say it hits something, you give it more time so that imagine behind, like I said, maybe 1000 kg, then in front maybe it's like a huge mountain. So if you hit something, you will hit the mountain, and then behind it will smash this guy. What will happen to this guy? Oh, bye-bye. All right. So we want to make sure that there is like some allowance of time, some extra time, so that if you hit something very hard, the inertia of this will not also go and crush the driver, or else this driver will become a sandwich, right? Hamburger, very disgusting hamburger. Okay. So we don't want that to happen. So you give it more time. Okay, later when I explain in the solution, I believe you guys will be able to understand what I'm trying to say. So at least you know inertia is actually just talking about this. Okay, first law and all, right? But inertia is really just, if you know this, you know everything about inertia. Right? If you want to say something high or low inertia, you just ask yourself, is it easy or difficult to stop or move? Okay. Okay, chapter 3. No time. Yeah, done. Let's move on. Oh no. Okay, 3.1. I will do the first two questions because the question 3 is on chapter 3.2. So for now, you don't have to worry in your exam. This one is chapter 3.3. Okay. This one is chapter 3.2. Okay, so we do the first two questions. Okay, let's do it. The diagram shows a coconut. A coconut and a mass of 3 kg located on the ground. State Newton's universal law of gravitation. It is the longest definition in chapter 3. Unfortunately, it is the most popular definition in chapter 3 also. Try to remember this. Very likely it will be asked. How to remember? Don't worry. Let's pull out our trusty formula sheet because it's always there for you. The answer is here already. You just need to know how to write it out in sentence. Okay, the answer is there already. You just need to know how to write it out in sentence. Let's try. F equals to G M over R squared. Okay, G M over R squared. So you just have to say the force and the M1, M2, they are both on top, right? If both on top, directly proportional. If you don't know what is this symbol means directly proportional. Then what else? F and got one more thing there, right? The R squared. The R squared. One is on top, one is at the bottom. This one called inversely proportional. So there's no symbol for inversely proportional. We still write it using that symbol. It's just that we put it underneath. Underneath is understood already. Inversely proportional. So the G, don't worry, the G is just a constant of 6.67 times 10 to the power of -11, the gravitational constant, even in exam. Don't worry. Don't need to memorize. Okay, state Newton's law of gravitation. Let's try. The gravitational force. That's F, right? The gravitational force. Normally, we say gravitational force between two things, M1, M2, right? Between two objects, two bodies also can. Two bodies or two objects, up to you. Is directly, so that was the F, gravitational force between the two things is directly proportional. How do we describe M1, M2 in English? Like in English, how would I write it? Is it the total? If I say the total, is it correct? The product. Yeah, multiply means the product. Okay, good job, guys. Good job. All this, okay, good students. Okay, right, the product. Yes, you cannot write the total because the total means the sum, means you plus. Product of the masses. Does it have to be exactly the same as how I wrote in exam? Don't have to. You write yourself lah. Product of the mass of, let's say you don't know, you get stuck. Mass of the first body and the second body. Can lah, can, no problem, don't worry. Okay, product of the masses of the bodies or the objects. Okay, so we're done already with the first guy. I know very long, but you learn to depend on the formula, right? Because the formula is given. And inversely proportional to the, how do we describe R squared? Huh? But there's a square lah. So normally if I want my English sentence to look nicer, yeah, I will write squared of the distance, the squared, very good, of the distance. But like that, not enough. You have to be specific with what distance is this. What is R? Okay, so R, I know they use R, but it is actually not a radius. It is actually not a radius. It is the distance center to center. Very important. Distance from center to center. Super duper important. Guys, I know chapter 3.1 got a lot of formula, right? You look at the formula sheet, you know, okay, got so many things, right? But you need to know, memorize don't need. What you need to know is what means what. You need to know what is R, what is G, what is all of that. You need to know the meaning of it and you know how to use it. So this is very important. Okay, I want to get to something later about this distance. Okay, but let's continue first. Distance, you want to write from center to center or between the centers also can lah. Is this very long? Yes, right? Very long. Do they like to ask this? Also, yes. So you got no choice. You got no choice. You have to learn how to get it up from the formula lah. Okay, so there is the F, and then there is the product of masses, that's M1, M2, and then divided by square of distance from center. Okay. Speaking of the R. Okay, very good. Speaking of the R, if I say distance above Earth surface is 700 km. Should I say, if the sentence gives you something like that, I'll ask you to calculate something, maybe objective, maybe structure, I don't know. Can I say that the R is 700 km? Then what is it? What is 700 km? Usually is what symbol? The H. Guys, yes, very good. The distance above the surface, if you ever get confused, it is never ever the R. It is never ever the R. So they are talking about maybe a satellite is here, right? Maybe the satellite is here. Okay. Above the surface, that one is called the height above the surface. But what is R? Center to center. It has to be the center. That is not center, right? So you need to also go and add with the radius of the Earth. As confusing as it sounds, usually we use big letter R to represent radius of different planets. Usually lah. But maybe your teacher make mistake and then they say, okay, the big R is the distance from center to center. Okay, you just follow along with the question now, right? But generally speaking, the small r is the center to center. So it depends lah. If the object is on here, okay, if the object is here, then what's the distance? Just the radius law, right? If it's on the surface, then it's just the radius law. If the object is slightly further, then you maybe need to add the height, no? Sometimes question very kind, they give you the distance from center to center straight. But sometimes not so kind, then you add yourself lah. Okay. So you don't have to memorize different formulas, because I think you guys know that your textbook, all your different reference book, even your tuition notes also maybe, they always like to give you many versions of it, many versions of this formula. Give you the R version, the big R version, the R plus H version. Do I remember all of that? No, I don't care about them, right? Don't need to waste your brain space. Just remember R is what? Center to center. Very important, very important. Center to center. So you see all these small r can be converted to different versions one. Okay, so one formula maybe they can create to 3 different formulas, but they're all the same. Okay, you learn things, you don't learn all different lines, all the same thing. You see all the r, it all means center to center. All of it center to center. Yeah, okay, that's very important because a lot of people fall into that trap. Okay, let's do the calculation, quick one. What is the gravitational force? So I'm going to use this formula. Just make sure everything is in SI unit. Mass of coconut was 3 kg, right? And Earth is... Do you know the difference between big M and small m? Mass of what and mass of what? Big, if they use capital letter and small letter, because sometimes they write like that also. Okay, we think about that first. So let me finish this. The distance from center to center is 6.37 times. Big M is a constant. You're almost true, almost right. Okay, you guys will get this. Okay, how to type in the calculator? So sorry, I got no time to teach you how to type. You type yourself, don't know how to type, ask your friends. Guys, big M and small m, another thing that people get confused. So small r was quite important. Remember, small r was quite important. A lot of the time, they like to change the mass into big M and small m. And big M is just the mass of the center body, which is always the bigger one. Okay, which is always the bigger one. The small m is always the orbiting body, and it's always the smaller guy. Okay, or it doesn't have to be orbiting, maybe it's on the surface of the Earth, but it's always the smaller one. Mass of orbiting body or object. It is always smaller. Is it difficult to remember? Smaller guy, small m, bigger guy, big M, right? It's logical. I got logic on everything. Don't just memorize things as it is, right? Physics can be fun, I hope. Okay, so you have this. And guys, that is the first thing you need to know. In chapter 3.1, I say got 4 things. I'll tell you all 4. First thing you need to know is how to get your gravitational force, how to calculate, how to write out the law, all right? So it's all under that category. Mostly calculation, state the law. If you can do that, you're usually fine. Gravitational force. Number 2, okay, is this part C. Sketch a graph to show the relationship between gravitational acceleration and distance from the center of the Earth. You need to know this graph. It first goes up until it reaches big R, and then it comes down. So for this part, we say that this is, to those of you who don't know. Okay, I suddenly thought of another thing. Okay, wait first. Okay, so this is the center of the Earth, right? So you go until here. So this point is known as the big R because this is the distance, right? So when they say big R, it means, of course, it's the radius of the Earth. But really, it just means that it's on the surface of the Earth. Okay, normally we know that, okay, if it's 0, then it's at the center, right? If it's 0, then it's center. And then if it's here, then it's the radius of the Earth. Then if you go further, then you have more and more distance, then it's further. So very logical, because the further you go, the weaker the force. Wait, the further you go above the surface, the weaker the force. Okay, the weaker the force. And the weaker the force, the smaller the G. That's why the graph go down. Okay, the smaller the G. The further you go, the smaller the G. This is at the surface, guys. Usually this value is what? What is the value usually on Earth? Okay, very good. 9.81. Unit is meter second, because it's acceleration. This is for Earth, for Earth. I can draw the same graph for other planet also, but just the value change a bit. Okay, so the further you go, the weaker the force. But guys, at the same time, I know a lot of you will ask me, teacher, what about this part, right? Why is it like that? Why does it keep on increase? Because you think of it like this, the logic is that at the very center, so your Earth, right, slowly grow from a small size, become a bigger size, as time goes by. So at the very beginning, it had 0 G value. The G value was 0. And then the more mass it has, the bigger the G value, right? So it slowly grows the value until it reached the surface. Are we usually concerned about this part? Usually not so important, because do we do a lot of activity underneath the Earth? No, most of the things that happen is above the Earth's surface. So you know the shape will do, that's enough. But we don't do things underneath the Earth, right now. We don't do a lot of activities there. So there's very little real life application of things underneath the Earth crust. Very little. So just know the shape will do. Yeah, the rest is not too important. So that is the second thing, which is gravitational acceleration. And you are trying to combine the force formula that you learned in chapter 2 with the force formula that you learned in chapter 3. I don't know if you all know this. They are the same. Okay, that is your G. Is it important to know how to get to here? No, it's given. The G value is given. So for the second thing that you need to know is what? All about the G, okay? This small G, small G, and also you need to know the shape of the graph, okay? You need to know how the graph look like. And so that's number 2. So first thing, what you learn? Gravitational force. Second thing, what you learn? Gravitational acceleration. Let's go into the third thing. Centripetal force. I got 1 minute left. I hope you all can stay for a while. Okay. Let's go to question 2. Okay, I'll show you this later again, so don't worry. Question 2 here. I will just go through the definition, what is important, what I need you all to know. Okay, the rest later, if you look at my answer, you will know. You should understand what I am doing. Centripetal force. Yes, okay. Just now got something I wanted to say. You all know the difference between big G and small G, no? This one don't confuse. This one is a constant, gravitational constant. It's an acceleration. Okay. Back to here. Centripetal force. Do you all know that centripetal force is actually gravitational force? Okay, so you need to know that because a lot of teachers, when they teach, they don't say that centripetal force is actually the gravitational force. Later I tell you why. But centripetal force, what is the purpose of centripetal force? So that the object can go in circle, right? So that the object can go in circle, is to maintain so keyword is what? Circular motion. If you cannot remember this in exam, never mind. You just say move in a circle. Continue to move in a circle. Circular motion. Number 2, very important thing for centripetal force, you need to know. What is the direction? Where is it pointing to? Where is this force pointing to? To the center. To the center. These 2 super important. You know this? You can tackle a lot of things. Okay, so what's the meaning of centripetal force? It is the force that maintains an object in a circular motion. Don't need to memorize word for word. You just put in the important things, circular motion, and always acts to the center of the circle. Important thing. So you guys need to know this. Huh? When your object go round and round and round, the force is acting here to the center of the circle. Okay, so your object goes round and round and round. That's the force. But guys, when we draw the force like this, a lot of people say they don't know why is it gravitational force and stuff. Maybe in the middle here, you got another object. Isn't the gravitational force the attraction force? Right? It's the attraction force, right? Look at the force. That centripetal force look like an attraction force as well. Same thing. That's why they are the same. That's why we can go and equal the force together and then give you a new formula, centripetal acceleration and so on. Right? So the force is to the center. Remember that. And if they use a string, to do this, this is the force. This is the centripetal force. But if they use a string, I can also call it the tension of the string. Okay, tension of the. So if you pull a string, it gets tighter. That tightness is called tension. Tension is a kind of force. Okay, tension is a kind of force. So if you pull the string, it gets tighter. It is a kind of force. So that is your centripetal force. If they ask you what is the tension of the string, what force does it represent? Centripetal force. Okay. Another thing, the velocity. If I ask you to draw what is the linear velocity of this object, and you say, oh, the velocity look like this because it moved in circle. gg.com, right? It is not like that. It is a straight line. In fact, it is a tangent. Yeah. Very important. SPM 2021 asks a 2-mark question. 1 mark, they say in the diagram, please label how the F look like. You just draw an arrow, label F, must point to the center. 1 mark. Mark number 2, they ask label where is the velocity. How does the velocity look like? Just draw like that. Done. 2 marks. You need to know how it looks like. Another question that they will ask, right, is like this. What happens if the string breaks? What happens if there is no force? What happens if the string breaks? Or let's say if you know, the hammer throw, there's a, have you seen those Olympic event that they hold a string, usually a metal string, and then there's this metal ball. Then they swing, and then they throw. Okay, I don't get how that is an event, but it is. So you swing, and when you release, when you throw, right, you are trying to break off the force. You're trying to break off the force. So where does the ball go? It follows the V. Okay, it follows the direction of the linear speed. Okay, so very logical. You look at this diagram, you cancel out the F. If you've got no force, the object follows direction of V. MRSM question, SBP question asked this before. Where does the ball go? What happens if the string break? They got asked this before. You must say it follows the direction of the linear speed. Okay, follows the direction of the V. Okay, I'm done. That is main thing you need to know for centripetal force. So I go back to here. Okay, are you done? So okay, maybe I bring all this stuff. Hold on, I'm not done. I need 1 more minute, just one. Bear with me. Okay, so I said centripetal force, that one is important. Calculation, I'm not so important, right? Because formula is given. You just need to follow the formula carefully. R is the center to center. Last thing, the most not so popular one is the how to calculate big M. Okay, it's mainly calculation only. Big M is mass of center body. Got 2 formula. One is from this formula. You just rearrange. You will get GR squared over G equals to big M. Okay, multiply the R squared. Slowly divide, slowly move. You get this. That's 1. Okay. Number 2 is on calculation only. That's why I say usually it's not that important. Second one is this 4 pi squared r cubed over gt squared. Need to memorize not the only given one, usually given one. Okay, so it's more on calculation on it. Most popular one, if exam until 3.1, must know this one and this one. Is it easy now? 3.1, 4 things you need to know. Okay, I know it's a very long topic. I hope this helps to guide you a bit. We are done for the day. I hope you learned something today. Good luck with your exams. Bye-bye. Okay, I will send the solution later. If you are done, you are free to go.